Hello and welcome to the next topic, which is advanced concepts of modeling. The topics which we will cover are revisiting AI and ML and DL, its subtopics, modeling, types of AI models, rule-based, learning-based, and all its categories. And this is very important. Lot of questions are asked from this part. And finally, the next topic is neural networks. So these are the topics which we'll be covering in advanced concepts of modeling. So the first is the three things, what is AI, what is machine learning, and what is deep learning. So as you can see from the diagram, artificial intelligence is the biggest circle and it has a lot of definitions. One of the definitions is it is one of the branch of computer science which tells the ability of a machine to imitate human intelligence. So artificial intelligence means a machine is able to take decision on its own without any human intervention. So if you have to identify something, whether it is AI or not, you just have to see whether that particular device is able to take decision on its own. No human intervention will be there. Some of the examples of AI are playing games, answering different questions, recognizing faces, voices. So these are all artificial intelligence concepts. Coming to machine learning, well, the machine learns from the data. The machine is trained and it keeps on improving without being explicitly programmed. That is what is machine learning. Some of the examples are again email spam detection, movie recommendations. So this is a part of AI or subset of AI. Deep learning is another subset of machine learning where the device learns using algorithms which is inspired by the human brain. The way our brain works on the similar concept, this deep learning works. Examples are face recognition, voice assistance, etc. Machine learning. Well, machine learning enables a machine to improve at tasks with experience. We will see this in more detail. Here is an example which shows you labeled images of apples and strawberries. These are given as input to the machine learning model. Input means apple. We are giving picture of apple and telling the model that this is an apple. It is a tagged image. The image is tagged that this is a strawberry. So we are basically training the model. Model means machine learning algorithm. We are training that if you see a object like this, which is sort of red color, this is the shape, it looks like it's an apple. And we are showing different images of apple to the machine learning. And this is how it is learning. It is getting the training. So machine learning model basically learns from the input data to classify between apples and strawberries and predicts the correct output, as you can see here. So when you are asking the device after training, what object is this? It is able to tell that this is an apple, because when we are giving it training, it is learning the patterns of how the apple looks. It is learning the features of the apple. Some of the examples of machine learning are object classification. So what is happening here? We have trained the machine with different types of objects. Here the examples are shown of that of different trousers and these things, all different types of clothes. So it is very easily able to identify different clothes. So this is one of the application, object classification. Another is anomaly detection. So anomaly detection means is there any problem with the heart rate or health something different than normal is called anomaly, and to detect that we can use machine learning. Next, diving into deep learning. So these are algorithms which learns on its own from examples, and it uses many layers to learn. That is why it is called deep. That is why it is called deep. The word deep is used because of that. And it becomes better with more data. It works very well with lots and lots of data. So we can say this is a subset of machine learning that uses neural network, which is inspired by human brain to learn from data. So as we can see in deep learning, input is given to the deep learning models, the different layers of neural network, and from that it tries to identify, here a picture of a bird. It is trying to identify that this is a bird from pixel level. It tries to identify a bird from pixel level, and finally when you ask what is it, if it is trained with bird, it tells that this is a bird. Some of the examples of deep learning are object identification. Once again, object identification in deep learning means we are using neural network to help a computer recognize and name objects in images or videos. Deep learning models learn from thousands of images to identify objects accurately. Next is digit recognition. In digit recognition, again the deep learning model is used where we can identify any type of handwritings, especially if you are not able to identify handwritings in a prescription. You can upload it and we are able to, it gives a very good output. It reads the prescription very well. So here we are using the process of neural network to recognize or identify any objects in images or videos. There are certain terminologies which we have to know. So starting with the terminologies, first is what is data. Data is the raw information which is collected for an AI system. It can be marks of students, it can be images of handwritten digits, it can be prices of house, it can be anything, any information, temperature readings, anything. Data is the foundation of AI. It is called the new gold. Data is the new gold. Next terminology is features. So what are features? Features are pretty simple. All the different columns in which our data is arranged are called features. So here we can say this is one feature, this is another feature, this is another feature. So all these are features. But out of these we can see, out of the three columns, we can see the feature fruit is special because that is actually telling that this particular column contains fruit. So these type of special features are called labels. These type of special features are called labels. And labels are of two types. It is labeled, data can be of two types, labeled or unlabeled. Labeled data means whatever the data is, it is carrying a tag with itself. It is carrying a tag, like this is a dog, this is a cat. It's carrying a tag. Like all of us have names, we carry a tag with ourselves. Similar. Unlabeled data means it's a simple, just a data. These are the unlabeled data. It's just data. No tags are attached to it. The next is terminologies related to training versus testing dataset. So we have to remember one thing. Data is divided in data acquisition phase. Data is divided into training data and testing data. Training data is used to teach the AI model during the modeling phase, and testing data is used to test the AI model during the evaluation phase. And always remember, training data usually is a labeled data, whereas testing data, which we use to test, is new unseen data. Training data is never used as testing data because that is not going to yield a fruitful result. Model learns patterns from the training data. From the training data, model does not learn the data itself. Model does not memorize the data. It learns the pattern in the data. And testing data set, what does it do? It just predicts, try to predicts from the testing data set what will be the answer. Predicts means output. And so this is used in the model building phase, and the testing data is used in the training, is used in the evaluation phase. You should know the difference between testing and training data, and if it is asked for 2 marks, at least mention 4 points. Modeling is a process of creating an AI model that can learn from data and make predictions or decisions or gives us some output. So we can say in simple words, a model is like the brain of an AI system. So let us quickly see the different models. There are basically 2 types of models which we are going to see: learning based and rule based. Under learning based, we have got machine learning and deep learning, which we have discussed what is machine learning and what is deep learning. Under machine learning, we have 3 types: supervised learning, unsupervised, and reinforcement learning. And under deep learning, we have ANN, artificial neural network, and the other is CNN, convolution neural network. Now, you have to know this structure. It is very, very important. Under supervised, again, we have got some subdivisions, which we will see. So beginning with what is rule-based approach. So rule-based approach is a method where a computer works using predefined rules. There are certain rules which we set for the computer to follow. The rules are in the form of if then else statements. So the device, so the computer checks different conditions and follows a particular branch of if then else. Most commonly used rule-based approach are in the different chatbots which we use, which we see in the customer care. Suppose you have bought an item and you are not satisfied, you want to return to it. We usually get connected to these rule-based chatbots which ask us few questions, and we just select those questions and proceed. So rules and data are fed into this system, and the system provides us with different answers. Certain drawbacks are there of rule-based approach. The first drawback is once the system learns, it is forever, it is static. You have to change the entire rule to make bring some difference. Second is machine once learns, that's what I told you, it cannot improvise on its own. So learning is static, it cannot improvise, and it does not learn from mistake. It does not learn from any type of mistake which it makes. Next is learning based approach. In learning based approach, here an AI, this is an approach in which the computer learns from data and experience instead of following fixed rules which are defined by human. So this is a method where an AI system learns patterns from data to make decisions or predictions. Learning based approach, we all have already seen machine learning and deep learning. That's what I told you, that in learning based it learns the patterns. So for example, there's a system which has to detect an email, whether it is a spam or not. Will be going for learning based approach because the system will be trained with a lot of emails. Spam emails usually contain some keywords which are learned by the system, and it finally comes with the output that this particular word is a spam, and next time it sees that, it classifies it as spam. Advantages of learning based approach: learning is automatic, complex problems can be handled very easily, and of course, yes, improves with experience. Some of the limitations are always there. Lots of data are required here, and training takes usually a long time because lots and lots of training has to be provided, and result also depends on the quality of the data. If you are training using good quality, you'll get a good output. Learning based, first comes machine learning based. These are the different models or algorithms which has to be learned. Under learning based is machine learning and deep learning. This is under machine learning. There are three categories, that is supervised, unsupervised, and reinforced. You have to know all the definitions. Under supervised, two models, classification and regression. Unsupervised, clustering and association. So now we will see each of these in detail. So machine learning supervised. What is a supervised model? Supervised learning is a machine learning approach where the model is trained using labeled data to make correct predictions. In this approach, the model AI model learns from examples where the correct answers are already known, just like a student learning with a teacher. So there's a supervisor who trains the model with the different inputs. Same example what we saw in that apple and strawberry one. So this is your supervised learning where labeled data set is used. The supervisor trains the model and we use it to classify objects. Problems or situations based on labeled data is fed to the machine. Supervised learning models, there are two types, classification and regression. Now we will see what are classification and regression models. Categories of supervised learning model, classification and regression. Definitions have to be done for both along with examples. So let us try to understand the classification model. In classification model, this is the AI model and we are in the training phase. We are trying to train the model with a picture of rose and telling the model that this is a rose. So we are training it with different pictures of rose. We are still in the training phase. We are training the model with different pictures of rose. This is our testing phase. This is our testing data. We are now giving this data and asking the model, what is this? So model has to label this. It has to give a labeled output since this is a classification model. Classification model gives us labels of different objects. So we have given it to the model testing data and it is giving us that this is a rose. So this is the work of classification model. So data used here is discrete. Discrete means data which is not continuous. Discrete means the whole numbers, data which appear in whole numbers, like your shoe size. This is a whole number. And continuous data are those which can appear in decimals, like our height is continuous, it is dependent on the previous data. Height is a continuous data. So data is classified according to labels. Discrete non-continuous data is used here. And look at the graph. This is very important. You might get a graph like this and you might be asked, identify the graph and explain. So you have to tell that this is a graph of classification under supervised model and write briefly about what is supervised model and what is classification. So classification basically gives predefined labels or tags to objects. So this is one of the example of classification. So to differentiate between hot or cold weather. So in this example, the model will tell us whether today is hot or cold to predict, giving the label. It will not tell us what is the temperature today. It will not tell us any number. It will just tell us whether it's hot or cold. So the labels are hot or cold. It will not tell us what is the temperature. That will come under prediction, not classification. Another example is to detect the category of email which is coming in the inbox, whether it's a spam or not spam. If it is spam, it will be redirected to spam folder. So this is again, we are classifying. It is getting the category as spam or just a normal email. This is another example of classification. That was all with the classification model of supervised. Next is regression model. Regression model uses continuous data. For example, here we see there's a girl called Smita, and this model has to predict what will be Smita's height in the 2026. So 2018 it was somewhere around 3.2, 19 May 3.5, and these are the different data. So we are feeding the model with all the different data of all the previous historical data we are feeding it of a particular person. And the model is running all the different algorithms and giving us the output that the height would be somewhere around this. Okay? So any type of prediction, wherever you find that a prediction has to be made, it is regression model. Regression is related to prediction. Predicting price of house, predicting weather, what will be the weather tomorrow. It is prediction. Outputs can be in numbers. So what will be the temperature tomorrow? Predict the temperature will come under regression, and will it be hot or cold will come under classification. So regression algorithms, as I told you, it predicts continuous value based on input variables. This is again a supervised learning where AI model predicts a numerical value. Please remember, regression, the output is a number, not a category. And look at the graph of regression. This is how the values are going, continuous values. Again, you might get a graph, or you might have to draw the graph of regression. Give a very good presentation with regression. Examples of regression. Again, predicting temperature. Any type of prediction you can give as example. If you are asked with the definition, please end your definition with a example for sure. Whether it's asked or not, you have to give a example. Coming to unsupervised machine learning. So we have seen supervised machine learning. This is unsupervised machine learning. In unsupervised, first of all, it works with unlabeled data set. So data is not having any type of labels. So data is fed to the machine and it is a random data. And there is a possibility that a person who is training the model does not have any information regarding it. What does unsupervised learning models usually do? They try to identify the relationship, the pattern, the trend of the data that is fed to it. And finally, they give us some output which will be based on the similar patterns. They try to give us outputs based on some similar type of patterns. We'll try to understand an unsupervised model. So again, in unsupervised, we have got two types, clustering and association. Definition of unsupervised has to be done along with the definition of these two models. So unsupervised, unlabeled data, and trainer doesn't have idea what the data is that is fed. And finally, the model itself tries to find relationship in the data. So clustering is a type of unsupervised learning model where AI system will group similar data points together. Again, I'm mentioning clustering data is not labeled. Another way of saying is this is a technique in which similar data points are grouped into clusters without labels. Without labels. So this is unsupervised clustering model where we are giving unlabeled data set to the AI model. And the model will give us an output based on the data. So we have given data set of different flowers, a lot of flowers. What did the model do? The model has tried to group similar type of flowers. It has tried to group similar type of flowers. So this is output of clustering machine learning model. So as I told you, the system tries to look for similarities such as size, color, shape, and different types of patterns, behavior. So data points are similar, are grouped together, and each group is called cluster. Look at the graph here. The different clusters are grouped here. So if you get a graph of this, you'll either see an oval around the same type of data points, or you will see circles. Not necessarily two circles, you might see three or four, and you should know how to draw this. So again, it's used for grouping of spam type. These are spams, identifying any type of criminal activities. So clustering unknown data according to the pattern or trend. Coming to examples of clustering. So here you can just go through this. They are trying to make clusters of students who are high scorers, average and low. So we can make clusters of any types. You can give any examples of clusters. One confusion comes here. What is the difference between clustering and classification? That's why I'm mentioning this. First of all, classification comes under supervised, and you know what is supervised. A trainer is actually giving a training with labeled data set, and clustering is unsupervised. So labeled data, unlabeled data. Here you have already got predefined classes. You have already told this is an apple, right? And the model now knows it's an apple. Here the groups are formed automatically. We don't know how the model will form the group. But if we are talking about classification, we know it will group all different types of apples together and say give the label that this is an apple. But here we don't know what type of group will be formed. So classification and clustering, you can go through this, and if the difference is asked for, you can mention these differences. Another unsupervised model is association. We are using it quite a lot. Let me give you an example. Suppose we are trying to buy, we are going to these different shopping websites, and I'm trying to buy a mobile phone. So once I buy that mobile phone, I do the payment and all, I get some recommendations. You might like this product for, say, it gives me for mobile cover, it will be recommending screen guards, it will be recommending me for charger wires. So these are actually related to the item which I have purchased. Here comes association model. So what is happening here? We have taken the example here from your book, like a customer A is buying bread, butter, and milk. Okay, so this is another customer is also buying bread, butter, and rice. So the model tries to see where is the relationship. So this is unsupervised model which finds relationships. The main thing is relationship or pattern between items in large data sets. It tells us what things occur together. It will not predict the value or class, it discovers relationship. So if the third customer now buys, if the third customer now buys bread, only bread, it will recommend it for butter, because from the first two customers it has seen that usually if somebody is buying bread, is going for butter also. So the third customer is only buying bread. Like I told, if I buy only the mobile phone, it will recommend me for mobile covers and all accessories of mobile related to that particular thing. So this is the work of association model. This is what is association rule. Reinforcement learning. Well, so supervised, we have seen two models, unsupervised, two models. This is reinforcement learning. This is again a machine learning where AI system learns by doing. System learns by trial and error method. And two things you have to keep here, you have to note, it's trial and error method and improves based on rewards and penalties. So if it is making any mistake, here the system gets penalties. And also we are also giving penalties. Sometimes we say we don't like this, it's a thumbs down. We say we like this, it's a thumbs up. So those are the rewards. It is learning that it has done a correct thing. So reinforcement learning, you have to remember that the decision is made on just, it keeps on trying and comes to a decision, and reward and penalties are the two words you have to look for, and trial and error method. So reinforcement learning, this is the model. Giving picture of an apple, it is predicting it is a cherry. The feedback is given as wrong, it's not a cherry. So next time an apple is given, maybe it will predict it's a strawberry, again wrong. So, but when it says it's apple, we give it a positive feedback. So now it's learned that this type of object is an apple, and next time it's asked, it will surely mention that it's apple. So parking in different conditions, robot walking, all these are coming under reinforcement learning. A quick summary of machine learning: supervised, unsupervised, reinforcement. Supervised is determining relationships through training. Unsupervised is discovering new patterns. Reinforcement is rewarding actions, learn by rewarding actions. This is very helpful. You have to remember all the names. We don't have any models under reinforcement in class 10th, but classification, regression, clustering, association is like you have to do this with examples. If you have any doubt, please drop in the message or comment. I'll get back to you. Next comes deep learning. So that was all with machine learning. Next comes deep learning. So this is again a type of machine learning that teaches the device to learn by using neural networks. So neural networks are always inspired by human brain. And why is it called deep? Because it uses many layers. We will see that in neural network. This is a subset of machine learning, as I already told you. And two types of deep learning are ANN, artificial neural network, and convolution neural network. We will see these two after this. So deep learning first is artificial neural network or ANN. This is a computational model inspired by the human brain. Like human brain has got a lot of neurons that passes signals, and artificial neural network also has artificial neurons, and these neurons are actually processing the information. So there are lots of nodes which are working as neurons here. What is convolution neural network? CNN. This is a special type of artificial neural network that is mainly used for image related tasks. So wherever image or computer vision is coming, CNN is used there. This helps the computers or the device to see and understand images the same way as we humans do. Coming to artificial neural network, first is what is a neural network? So neural network, as I told you, there are different nodes which are working as neurons, and neurons keep on passing information in our brain. Whenever we are trying to take decision, these neurons are helping us to take decision. The same way a neural network works and takes decision. This is the structure of a neural network. It is divided into multiple layers. One layer, another layer, this is another layer. These are different layers. And each layer has got these circles. What you can see are actually the artificial neurons, or these are called nodes. So artificial neural network, you have to first remember, it is divided into basically multiple layers, and each layer has got nodes. Coming to layers, actually there is one input layer, only one input layer, and only one output layer. There can be multiple nodes in one input layer, there can be multiple nodes in the output layer. Nodes can be multiple. Here it's single node shown. It's not necessary. You can have multiple nodes in the output also. But the middle layer, which is shown in green, is called the processing layer or the hidden layer. So input is passed from the input layer to the first processing layer, and every node is connected to all other nodes of the next layer. Please prepare a diagram of neural network also. You might get question for this. So each node is connected to all other nodes of the next layer. And all these nodes are actually running machine learning algorithms. So neural network consists of input layer, hidden layer, which performs the processing. Same like IPO cycle, input, process and output. Performs the computation. How does it perform the computation? It uses the concepts of weights and biases, something called weight and bias on each node. on each node. It is using weights and bias. And finally, the information is passed through these layers to reach the output layer. First layer of neural network, as we know, it's called the input layer. Job of the input layer is to take the data, feed it to the neural network. No processing happens in the input layer. No processing happens in the output layer also. Beside the input layers are the hidden layers. Hidden layers are the layers in which whole processing occurs. So their name essentially means that these layers are hidden and are not visible to the user. Each node of these hidden layers has its own machine learning algorithm, which executes the data received from the input layer. Hidden layer performs computation by means of weight and biases. This has to be remembered. And the process of finding the right output begins with trial and error until the network finally learns. With each try, the weights are adjusted based on the error found between the desired output and the network output. We will not go with the working of the hidden layer. You just have to know processing happens with weights and biases, and little bit of processing we have to do. For doing this processing, we have to understand something called perceptron. What is a perceptron? Perceptron is a single artificial neuron. Yes, it is part of a neural network. Of course, it is part of a neural network. This is the building block of a neural network. So perceptron, we have to do one working of a perceptron, how the perceptron works. We'll take up this example. I'm going outside. Should I carry an umbrella or a jacket? That has to be decided by my perceptron. It's part of the neural network, one node which will decide whether I have to carry umbrella or jacket. So if the answer is 1, it means we have to carry umbrella. If the answer is 0, I mean if it is 1, then we have to do that. 0 means, so it takes binary decision. Binary, either 0 or 1. So perceptron is one decision is made, one decision making unit. Neural network is many perceptrons are connected and that makes a neural network. What is deep neural network? Many layers of perceptron are there. So let us try to understand a small perceptron concept. Same example we are taking. The first input we are giving is it raining? Because if it rains, then only I'll be carrying an umbrella. And I'm assigning some weight to it based on whether it's raining or not. Like, same like our brain works. Yes, it's raining, I need to carry umbrella. So the same thing, the weight has to be assigned. If it's today's weather, if it's raining or not, the model is assigning that weight. Users are not assigning, model is deciding that weight. This is your model. Is it cloudy? Another weight given to this. So my second input is x2, and is it cloudy is my second input, and it has been given weight w2. Is it cold? x3, and some weight is being given to that w3. After this, I add my bias. I'm sorry, the model only adds a bias. As a model decides the bias and weights, which we'll be studying later, not in class 10th. So there's something bias. Bias gives an extra push to the decision. And what is y? Y is the output of this particular perceptron. How is y calculated? Y is w1 into x1, x2 into w2, and summation of all these things, and bias b. This is then passed through a activation function, and we get some value. So let's quickly see this. Answers yes, Vato will be carrying an umbrella, or no, jacket. So X1 is 1. If it's raining, is it cloudy? No. It's cold? Yes. And some weights are given to this and the bias. The calculation is like this. Y is equal to x1 w1, the same formula which I told you, and the bias. Bias can be negative also. If it's negative, you have to subtract the bias. And we put in all the values and finally we come with y is equal to 6. Always remember, weights show importance of inputs. Y greater than 0 means positive or 1. And if it's less than or equal to 0 means it's negative. So here we have got y as 6, that means it is 1. So for umbrella, it is going as 1. This is the output of one perceptron, whether I have to carry an umbrella or not. So say similarly, lots of perceptrons are working and coming out with output. Finally, all the outputs are going through activation function. And lastly, we are coming out with the final output. You have to know the working of one perceptron, which will be asked in the exam, and you should be able to do the calculation. This is the formula: input multiplied by that particular weight plus second input, second weight, third input, third weight. Please do the multiplication first. Whatever answer comes, add them, and the bias, just check if it's to be added or subtracted and proceed accordingly and come out with your answer. So this is the working of perceptron. So at the end, it's just that modeling stage focuses on building and training an AI model using data. A well-trained model prepares the system for evaluation and real-world use. So training is over. Our next topic is evaluation. Bye-bye.